Let's take a look at specific heat. And specific heat or specific heat capacity, and we tend to use this abbreviation, the C, although the S is sometimes used. Its definition is how much energy does it take to change the temperature of 1 gram of a substance by 1 degree Celsius. The unit is a combined unit. We have joules over grams times degrees Celsius. Sometimes you will write it this way. You will see it written this way. And that -1 simply means that grams and degrees Celsius is in the denominator. We can substitute Kelvin for Celsius. And why do you think that might be? Remember that the Celsius degree and the Kelvin degree are equal. Let's take a look at a bathtub full of water and a cup with a little bit of water. I want to heat both of these to 90 degrees Celsius. Which one is going to take the most energy? Most of us would say the bathtub because there is more water. It has more mass. Let's look at our second case. We have 2 cups of water, the same amount. This time I'm going to heat 1 cup to 50 degrees Celsius and the other to our 90 degrees Celsius. Which one of these two is going to require the most energy? We would say our cup that we're going to raise to 90 degrees. Well, the bathtub takes more energy because it has more mass. So mass is going to be important, and it's also in our unit. And temperature is going to be important, and that is also in our unit. I believe this might be 2 pages. Your pages are out of order in your notes, so find this page. When we're looking at the energy transferred, we're going to calculate heat. And that's the amount of heat in joules. It has an abbreviation of Q, a lowercase q. M stands for the mass, and that is in grams. C is our specific heat capacity, and its unit is joules per grams times degrees Celsius. And temperature change, this symbol means change, and temperature change is change in temperature, delta T, and that's going to be in degrees Celsius. When we're talking about temperature change, we're talking about taking the final temperature and subtracting the initial. This is a lot of units, and there are going to be values or numbers in front of these units. This unit especially will sometimes throw students. You do not need to do any calculations. This is just all of the units that go with the number that is the specific heat capacity. Specific heats are unique for each substance. That means we can identify a substance based on its specific heat. If you look, water has a 4.184 joules per grams degrees Celsius. That may look familiar to you because that's how we converted from joules to calories. And there's a whole list of them here, and I've added sand or silicon dioxide. It's approximately 1, so about 1/4 of what water is. When we calculate sig figs, we use everything except for the specific heat value. That value is not measured, it's given to us, and we could add a bunch of significant figures, but we round it to these decimal places to make it easier. Remember, temperatures, you're going to use the measured temperatures for the problem. So you're going to look in the problem and look for the lowest number of sig figs. That will be the number of sig figs in your answer. We're going to take a look at the specific heat of water and sand, and we're going to look at 2 different places, Nagpur and Hong Kong. If we look at sand, it has a small specific heat, and water has a relatively large specific heat. If we transfer some heat to that, let's see what happens. Notice that the samples were put in the sun, so they received the same amount of energy. Because the sand had a low specific heat, its temperature went much higher, where the water, since it has a high specific heat, is only about 1/5 of the temperature change. This has a lot to do with coastal environments. We have Nagpur, which is inland, and we have Hong Kong, which is coastal. So they have similar latitudes. We can see over here they have similar latitudes, but the maximum daily temperature at Nagpur is higher than that of Hong Kong. When the sun sets, they both start to cool down, but Hong Kong's temperature doesn't decrease as much as Nagpur. Hong Kong is surrounded by water, and the water has a high specific heat, so it warms up more slowly and it cools down more slowly. And this is why we love to vacation on the coast, because the temperatures are more moderate as compared to inland, where the temperature swings are greater. As they heat up again, the temperature, okay, they both get the same radiation from the sun, but the inland city, the temperature is much higher than the coastal city because the water can absorb so much heat before its temperature increases. Let's give this problem a try. This is often called Q equals MCAT because the delta looks like an A. We have a 16-gram sample, so we have mass. We have 5.8 joules, so we have our heat energy, our energy that has been transferred. We have our temperature, so we can plug in for our change in temperature, and we want to solve for its specific heat. And we want to know what type of metal this is. So the first thing we do is substitute in, and then using our algebra skills, we solve for C. And we end up with we end up with 0.20 joules per grams degrees Celsius. Right? We have 2 sig figs because our lowest value here is 2 sig figs, and then also our temperatures are 2. Remember that this is all just the unit. If we look over here, this is the unit. The question wants to know, is this gold? Well, gold specific heat is 0.13, so no, this is not gold. This is the algebra to show the units. Let's try another one. We again have grams, we have the amount of energy that's transferred, and we have the temperature, so we can solve for our specific heat. If we plug in and then solve for C, our specific heat is 0.24 joules per grams degrees Celsius, 0.24, and so our unknown metal is silver. When we do these calculations, we're finding the change in temperature of something. And right now, we're just doing liquids. So we're talking about this slope right here. Later on, we'll use the same type of calculation to do solids and gas. So we are talking about changes in temperature of a substance, whether that be solid, gas, or liquid like we're doing now.